والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Thank you very much for the invitation. I'm glad and delighted to make a keynote presentation today on a very hot topic related to the agentic artificial intelligence. So the title of the talk will be The Rise of Autonomous Intelligence with Agentic AI. And I'm going to take from the history, now the history, it's actually just 5 years ago. It's not something like hundreds of years ago when we started to talk about large language models and generative AI in public. So the objective of this presentation is to make you an overview about the very quick evolution, the exponential evolution of generative AI from large language model that can generate next word or next tokens to complete complex agentic AI frameworks. So this is going to be almost the roadmap of today's presentation to talk to you about what is agentic AI. But before going into that, I'm going to start from talking about the rising of predictive models 5 years ago through pre-trained LLMs like ChatGPT, which is the first instance that has emerged back in November 2022. And the evolution to instruction-based large language models, which we call fine-tuning LLMs, to be able to perform instructions of downstream tasks. And then coupling with tool calling and function calling, we had the rise of single agent LLMs until finally we have what we call now agentic AI and workflows. And basically, an agentic AI is composed of 4 main components, which is about planning, having a memory to memorize all the previous discussions, ability of reasoning, and also tool integration. اوكي سو ان شاء الله من خلال المحاضره هذه باش نتكلم على 5 مراحل اللي او 6 مراحل اللي مرت بها اللارج لانجويج مودلز until we reach the agentic AI. So the first step, it started back in 2018, 2020 or 2020 back when people start to talk about generative models. So there are models that are able to generate text according to compliant with the linguistic characteristic of the language. And the idea here is this language model were trained on a massive text corpora, and they have raised several categories of language model like GPT-2 back in 2018, and then GPT-3 back in 2019. And so how does it work, transformer-based pre-trained model? The principle is the following. So given a certain context, مثلا عندنا جملة الآن, okay, and the objective is that the language model is able to predict what will be the next word. مثلا هنا الجملة الفأر يحب أكل. So the objective is to find what is the most likely word that comes afterwards. Of course, there is a whole pipeline through which this whole context is going to go through, like starting by tokenization, text embedding, which is the vector representation of this sentence, to extract the feature, and then we have transformer block to extract the features. And finally, at the end, we will have the probability of all the words into the vocabulary, and we can select the highest probability words or among the most high probable words. So this is basically how a generative model works in practice. We can see this in more detail if we want to look at this technically. So you can assume that you have a sentence, جملة هنا مثلا مقسمة إلى كلمات. In the beginning we need to tokenize it into different tokens, أجزاء من الكلمات, and then we need to make a vector representation because machine learning only deals with vectors. And this is what we call word embedding. And we need also to encode the position so that the model can learn the position of each word with respect to the other. And then we have a module for feature extraction. So you can think about multi-head attention like convolution neural network in computer vision applications or in RNN for extracting the features of sequential models. So multi-head attention is based on a mechanism called self-attention, and it is very powerful in capturing the relation between the different words into a sentence, okay, through a special mechanism that is called query key and value. So just think about this module as extracting the features and the relationship between the different words into a sentence. And then there is a classical layer normalization, which just for the convergence of computation in deep networks. The next step after extracting the features in the relationship, it will go through a dense network, which is a feed-forward network. And basically, this network try to incorporate all the different features extracted by multi-head attention and combine them into a single feature vector, which we call feature digestion. It's like digesting all the features to have a very meaningful representation about this sentence. And afterwards, it will go through a softmax function, which provides the probability of all the words into the vocabulary, and then we will select maybe the highest probable word or among the top 10 probable words. This is how a transformer architecture, and if we select the most probable word, so this will be the next token. This will be the next word that we will append to our context. طبعا الآن this module is very important because it will combine all the different features into a single vector. ثم البحوث اتطورت فيما بعد قالوا why we should have only one fully connected network to digest the features. In very complex corpora of text, maybe we can extract different type of features depending on the context. مثلا في بعض الكونتكست خاص بالكودينج، في بعض الكونتكست يكون خاص باللغة العربية، خاص باللغة الإنجليزية and so on. So the idea is like we have multi-head self-attention modules to extract different type of relationship. They have proposed to use different dense neural network, and this is what we call the mixture of expert. So every dense neural network will be able to run some particular patterns out of the features collected in the previous feature extraction with self-attention. والمixture of expert, it has several advantages. أول شيء, so all these neural network are going to learn, but at the inference time, we can only invoke a subset of them. So in this case, this is going to make the inference much faster لأنه ما عادش نحتاجوا كل fully dense network. We will only need a subset. وهذا ممكن نلخص لكم بطريقة بسيطة جدا. تخيل مثلا هذا طبيب عام يفهم في جميع الأشياء، طبعا يمكن يجاوب على كثير من التساؤلات لكن مش بصفة مدققة. الميكسشر اوف اكسبرت في عوض باش نجيبوا طبيب يفهم في كل شيء، نحاولوا مثلا يكون عندنا أطباء متخصصون، كل شخص متخصص في مثلا مرض معين ولا special treatments. And here we have a routing. We can think about as like the nurse that will select based on the symptoms. We're going to redirect you to the expert number 1 or expert number 3 or expert number 2, depending on which expert is likely to help providing the best service. So this is just to make a simple analogy of the idea of mixture of expert. It's just diversity of the dense neural network. So to make things simple, so basically a pre-trained large language models given a certain context, which you see here in green, okay, based on this, we try to predict what will be the next word according to certain probability. And now if I identify these users is the next word, now we will have a new context. It will go through another iteration through the transformer to select the next one until the end of the sentence. So this is the first revolution of making pre-trained networks. So these transformer-based pre-trained models are excellent, but they are able only to generate text. They are not able to answer questions. They are not able to write code. They are not able to make translations. So مثل شخص فقط يعرف لغة, but it doesn't know to do any task. So at the second stage, the next evolution is to make instruction fine-tuning. We take a pre-trained large language models and we will teach this model to perform different tasks, which we call downstream tasks. For example, making text summarization, explaining a concept, writing a piece of code, translating from 2 different languages. And in this case, we need to have a human labeled instructions to teach the language model how to perform these tasks. So to make the things summarized, we start from a base model, which is a pre-trained model. And then humans will collect an instruction fine-tuning data set. For example, we can have some human conversations to teach the model how to respond to customer service support. We can have expert response, collect expert response. So the model will be trained on this. We can train, for example, to write codes translate text, we can think about any kind of downstream tasks. And then we will go through the fine-tuning process. We start from a base model, and then by training again over this fine-tuning data set, we're going to have a better smart assistant. And the results usually are much better than instruction pre-trained models, which only know how to generate a text. So the benefits of fine-tuning, they help reduce hallucination a lot. لأنه الآن pre-trained language model أنا تم تدريبهم على static data. So if you ask any question that is recent, that was not part of the training data, the large language model will not be able to answer. I remember when ChatGPT was released, I asked who won the last World Cup. كانت بعد كأس العالم بتاع قطر. يقول لي مثلا فرنسا 2018. So because it was trained on the data only back in 2018, but now we can actually augment the knowledge of the large language model by making instruction fine-tuning, better task alignment, and also better safety. But still, it's not sufficient. It can mitigate the problem, but not solving the problem. And in addition, in parallel to the fine-tuning, there are some parallel research related to prompt engineering. الهدف منها تحسين مهارات language model حتى instruction based fine-tuned models. Some of the most popular prompt engineering attempts اللي هم reasoning approach, chain of thoughts. مثلا لما نسأل سؤال ندرب النموذج أنه doesn't respond immediately but try to think some kind of logical reasoning to solve the problem. For example, I can ask a question, for example, to solve this particular math problem. It will make a simple reasoning. To solve 15% of 80, I need to convert 15% to decimal and then multiply this value by 80, and then I will find 12. And this is a way on how we teach the model to make reasoning. There are also other reasoning approaches like the tree of thought or React. React, this is very popular, okay, because it will combine reasoning with simulated action. I'm going to talk about this in detail. Other attempts trying to teach the fine-tuned models on how to output structured outputs using few-shot prompting or role-based prompting or instruction fine-tuning. And other approaches that target to have more self-consistency. It means we reduce the error, the semantic error of the generated text by, for example, asking the language model to generate multiple responses and then select the most consistent ones. مثلا في عوض باش يختار من إجابة واحدة باش يعمل 5 إجابات، وإذا كان لقى 3 إجابات تتفق يقول okay, this is the correct response on how we can make it. So just in summary, there are multiple prompt engineering approach that attempted to improve the performance of these large language models. So the most popular reasoning approaches now in 2025, we have React, okay, which is reason and act. And here it is used because it integrates reasoning with action taking for external system interaction. نخليه يفكر قبل ما يقوم بالتنفيذ. A tree of thoughts, it's also emerging, but the most prevalent one who are React. It explores multiple strategies, okay, to take complex action. يحاول يعمل several heuristics. مثلا تعطيه سؤال يقول لو مثلا هذا الحل الأول، هذا الحل الثاني، الحل الثالث. So exploration of different possibilities and then take a decision based on this exploration. A chain of thought also, it's widely used. It ensures reliable multi-step reasoning for complex tasks. والself consistency تكلمنا عليها الهدف أنه to improve the consistency of the results. So which approach to use for which tasks? غالبا, if we have general tasks, React is very general. It has versatile reasoning and it can use special tools and APIs to perform extensive tasks. And we will talk about the use of tools. And planning a chain of thought is a good approach. It has traceable reasoning because it works step by step. For strategic, we can use tree of thoughts, and for improving the accuracy, self-consistency is a good way. Okay, so the third stage, now we made instruction fine-tuning, لكن بعض الأحيان لما تكون البيانات المدرب عليها مثلا سيئة ولا ما أخذها من السوشيال نتورك، الأوتبوت of the large language model قد يكون سيء. It can, for example, generate toxic words. So the objective of reinforcement learning with human feedback is to align the output with respect to the human preference. العملية بسيطة جدا كمبدأ. Okay, so for example, we're going to have a set of humans that will make manual ranking about the output, and then we use the human ranking as an input to the large language model to learn again. مثلا, we can ask a human, how can I make money quickly? So there are three possible ways. We can say high risk investment, that's correct answer, balanced ethical advice, and legitimate side gigs. Now, humans are going to make scoring, and maybe this is going to be the preferred one, B the second preferred one, and A it's the least preferred one, because this is kind of high risk. So we don't want the large language model to generate high risk responses. And then based on the feedback that we collect from human, we're going to make a reward policy for the large language model to learn, and this will align the generation into the human preference. So that is a popular approach to improve the accuracy and human alignment preference of large language models. Okay, that's excellent. Like the large language model by itself, at that point in time, it was used for both knowledge and reasoning. لكن from knowledge perspective, it's limited. لأنه تم تدريبه على بيانات محددة. Okay, so it's not able to cope with recent data, and also it doesn't have good capabilities, for example, to write code or make mathematical computation. So in this case, the objective was to integrate LLMs with existing tools and APIs. So this stage number 4, it has improved the LLM capabilities by allowing them to call functions. For example, you can call a function that will calculate the average or statistical analytics, or for example, can call an API to find the weather. We can think about any kind of tools. And this has augmented the capability of LLM from text generation to action generation. And this is the first stage that has allowed to the emergence of what we know now as agents. Okay, because agents basically they rely heavily on tools. We can think about different type of tools like calling APIs or calling, for example, internet Google search to find the recent data from the internet, from the news. We can think about third-party extensions. Anything can be integrated into a large language model through the capabilities of function calling. And this will allow the large language model to reason about which tool to use depending on the question, depending on the query. Okay, and this is how it works. So you have a user query. For example, I want to find the Tokyo weather and suggest activities for today. So when we send this query to the large language models, it knows the list of tools that it has with him, and then it will be able to identify which tool to use in this case. So in this case, it will know it can use a particular API that it has to make a function call, getting the data in real time from the weather API, and finally make a complete response to the end user. Okay, that's one of the usage of APIs as tools. So this makes the LLM go beyond text limitations. They can work with real-world tools, bring real-time data, and make task decomposition to execute different type of tools related to one query. We can think about also databases, accessing databases. So one of the chatbots that we have developed is to access the database of real estate and collect for example, I want to buy an apartment in a certain location. So just with a human query, we can convert it to an SQL query and bring the right data back to the user. الآن التولز كثرت. أصبح we have heterogeneous type of tools which make the function calling and the tool usage very complex. منذ أشهر قليلة Anthropic اللي هي قامت بالكلود LLM, they have proposed a protocol that is called Model Context Protocol. And just to make the long story short, it's like REST API. For those who know service-oriented architecture, it's a REST API for the resources in AI. So for example, if you want to call a database, if you don't use the MCP protocol, you need to make a special agent for this database. You must know the credentials. you must make special configuration for this particular type of database because there is no standard protocol on how to communicate with different databases. Same thing, if you want to change the database, you need to change the whole activity. Now with MCP, resource providers, they can expose different type of resources to a unified protocol. And this makes the integration of external resources much more easier with large language models. This is making a revolution right now. This is one of the latest trends in tool calling with large language models. One of the applications of tool calling is the retrieval augmented generation. And the objective here is not to rely on LLM anymore about knowledge because the LLM knowledge is static. So we want to have real-time data, private and domain-specific information. And this is why we use RAG. So what is RAG in short? RAG just combine retrieval with generation. So when a user asks a query, we're not going to let the LLM generate immediately the answer, but first of all, we're going to try to find the best answer from an existing data set. For example, I want to know when is the registration date of a university. So this information is not available into a large language model. But if I provide, for example, I tell the large language model, this is the university website, and before answering the question, make a search, try to find the information from the university website, and then append the search result with a query and send it back to the user. And this is what is happening actually. Okay, so when a user sends a query, we're going to send it to retrieval component. The retrieval is going to try to find the most relevant documents related to the query, and all of these documents will be sent to the query to the large language model to generate back a response. Okay, and this is maybe it's easier to figure out. Now, this is the first step, generating a query. I would like to know the registration date for the next semester. Now here we're going to use a semantic search. It can be through a vector store database or maybe searching the internet. We will need to find the information and then append the information along with the query, send the response along with the question to the large language model. The large language model will have sufficient context to generate an answer, and finally we will send this answer back to the user. And here we have different components. We have the retrieval components before the generation. We need to bring our data source, which is a set of documents that we can vectorize and create a database of vectors. And this is what we call a vector store. And finally, to do a generation based on the answer that we collected from the retriever. So all of this past, it has facilitated the notion of agents. But at some point in time, so the agents that were created are single LLM agents. So they can actually perform very limited amount of tasks. It's only one agent that can make different type of function callings. So this agent, it can make planning, it can make reasoning, it can make observation, but there is no coordination with other agents. And one of the most popular framework for single agent LLMs is the LangChain agent executor, which you can use, for example, to call a database, to make a search, to retrieve documents into a vector store. With a single agent, you can do plenty of things, but there is no orchestration among different agents. So this was very popular, very promising, and solved a lot of issues. But with the complexity of the tasks, it could be limited for several cases. And this is the last stage now, which is the biggest trend in generative AI, is actually to use a crew or a team of agents to solve very complex tasks. And any agentic AI workflow, it will require a planning component. It will require to have access to external tools. And also, it must leverage the reasoning capabilities of a large language model. So these are the pillars or the key architecture enabling agentic AI components. The agentic AI must have the ability to plan. And for this, we can use the prompt engineering techniques that we have introduced, like the chain of thoughts or the tree of thoughts. These are viable solutions to help the large language model agent or the agentic AI framework to plan. We need also to have memory. because we don't want because the agentic AI is going to make several complex tasks that are interrelated. So it must remember all the phases that it has to go through when it's responding to the question. This is why we need short type of memory and long memory as well. And LangChain is doing a great job in providing different type of memories for agentic workflows. Also, the agentic workflows must be able to reason, to make reflection, to analyze their mistakes, and to improve over several iterations. And also, they must have access to external tools, as already mentioned. And now, if you want to build a multi-agent system, you must have the attitude of separation of concern. For example, you can have a multi-agent system, one agent to write code, another agent to review the code, another agent to plan strategies and coordinate among the agents. So think about, for example, you want to build an agentic application for customer support service. How are you going to build this? So it's like now you will recruit some employees. You will have one employee that will just be the service agent. It's the agent that will interact with the user. Another agent that is product manager. Okay, so he's going to check whether the product exists or it's missing, and have access to real-time inventory database, provide detailed product specification, and so on. Another agent will be responsible for financial services, like for the payment. And another agent can be used, for example, to support the users and improve the user experience and resolve customer complaints. This is how we think when we build multi-agent systems. So the coordination among these agents, it's a very complex task. And for this reason, there are several multi-agent frameworks, including LangChain, AutoGen, and CrewAI. I will try to skip some details just to try to close the loop within the allowed time frame. So these are the three popular frameworks, and I'm going to provide you a brief overview about the differences. One of the most popular ones is LangGraph, which is part of LangChain, and it is based on the graph or state machine framework. It has a router that can redirect a user query to a particular path in the graph. And this is how it works. So you can define different type of agentic workflows. For example, here, you receive a query and you have an orchestrator, and you want this query to send the same task into parallel workers. So this worker is going to write something, another worker is going to review the output. So we can think about different type of assignment of a particular task into an agentic workflow. And these workflows will depend from one framework to another. So what I like in LangGraph is that it provides a very specific way on how to coordinate between different type of agents. So it's more controllable than the free agent style. You can have a free agent style where the coordinator is going to decide which agent to execute which task at any time. But with LangGraph, you can have more flexibility to identify particular paths of execution as compared to other frameworks like AutoGen or CrewAI. So LangGraph, it supports augmented LLMs with memory. It's able to maintain states and nodes. So it's based on the concept of state and nodes that define a particular graph. Let me give you a simple example. Imagine that you want to write an article from user description until the end. So this is a very simple application that we have tested. So you can provide your requirement of the article. I want to write a state of the art about agentic AI. So you have a first node, which is a first agent that will make the plan of the article. Another node that will write according to the plan that is generated by the previous agent. Another node that is going to review the written text from the writer agent. And then you can have another node that will fix. So this is another writer that will fix, sending back to the review, several iterations until at the end the reviewer agrees on the output and finally send it to the submit node. This is one of the applications that we can implement as an agentic workflow in LangGraph, and this allows to make iterative refinement until a convergence. So other frameworks like AutoGen from Microsoft also defines agentic AI from different perspectives, where they define an agent that interact with the user, an agent that is able to perform some tasks. It's called assistant agent, and user proxy agent for user interaction. So I know there is no enough time. I don't want to provide. I have the slides I can share afterwards, but let me just skip to present. AutoGen provides different type of interaction. Like for example, you can set up agents for math problem solving or for retrieval augmented chat generation or to make decision making or even for completely conversational agents. Look, for example, you can create an agent between two AI agents to play chess without human intervention. So this is an excellent framework that I recommend you to explore if you are interested also in in AI agentic workflows. The last one is about the crew AI, which also has a different definition of agents, which is basically on defining, it's like you have a crew or a team of members. Every member will have a specific role, will have a specific job description, and has a specific goal to achieve. Okay, so basically all of them they use prompt engineering. They use different system prompts and different type of implementation depending on how they perceive the execution of an agentic workflow. And this is an example, a very good thing in Crew AI agents. You can write code, but also you can define an agent without coding. Okay, you just need to specify a YAML configuration file about what are the agents and what is the system prompt for every agent, and then Crew AI will be able to create these agents for you without having to do much coding. So this slide summarizes the different agentic frameworks and their comparison. And also, we can do the same thing with these different frameworks to achieve the same task. This is a code, three different codes for the same tasks of writing an article. Just 2 days ago, Microsoft has released a report about the security risks and the common failure of agentic AI. So agentic AI are very promising, but they are still prone to security risks. For example, AI can be tricked to leak company secrets. So you need to be very careful about what information you expose to the AI so that it cannot be disclosed to external entities or unauthorized. It was identified also to prioritize task completion on human safety. And one example is that a lab robot continues experiment ignoring nearby humans at risk. And also there are some other issues related to wrong medical instruction, providing wrong medical instruction, causing potential harms, and also AI email assistance forward sensitive project emails to a hacker address. These are some security risks identified on recent agents. Now, the biggest trend in agentic AI is Code Act. وهذا اللي يستخدم فيه مانوس إذا كان سمعتوا به في الأخير اللي هو the first chatbots that used agentic framework to respond to questions, to complex questions. والفكرة هنا بكل بساطة أنه قبل الايجنت كانوا يستعملوا JSON structure to identify which tool to call. Now with Code Act, from a query is going to be converted directly to a Python script to execute and to respond to this query. And this has been shown to minimize the conversions. Look now, just look at this comparison tool. When we use a code as action into an agent, we are able to achieve a high success rate in smaller iteration time. Okay, what you see in green here, this is the success rate, almost 70% completion with only 4 iteration in average. However, using the same language model, if we use, for example, JSON as an action, it will have smaller success rate with longer iteration time to complete. And Manus, this is the interface of Manus chatbot, which uses this Code Act agentic framework. It's very, very advanced. I think now it is open for public, and you can try it. It provides very, very advanced type of responses. Thank you very much for your attention, and I will be happy to receive your questions.
40 people, half of them are PhD students and master students. And so the future, what kind of role they will play in the future, and how these agents, multi-agents, and agentic system will impact the career. And also, we are still a little bit young, so how this will impact our career as teachers and researchers.
اوكي الله يبارك فيك شكرا على السؤال. So agentic AI actually it's now the future about generative or let's say general artificial intelligence. With general artificial intelligence, is an artificial intelligence that is able to solve almost any kind of tasks that can be solved by a software. And now we start to talk about حتى في مسألة التوظيف. مثلا شخص الآن عنده شركة ويحب يوظف موظفين مثلا ماركتينج ولا كاستمر سبورت، ممكن مش نغيروهم نهائيا بالاي اي ايجنت. and we can have an AI agent for customer support 24 hours. It's able to respond in human like responses سواء كتابة أو حتى بالصوت. الآن فريم وركس أصبحوا يجاوبوا بالصوت بجميع اللغات with different dialects. فال AI is going to take over jobs but it will create other jobs as well. هذا سواء في الوظائف العادية أو حتى في السوفت وير انجينيرينج. أنا كانت عندي مداخلة قبل شهر أو شهرين حول مستقبل السوفت وير انجينيرينج في الجينيريتيف اي اي. طبعا الآن مثلا 19 معناها there are expectation أنه 99% of the code will be written by AI by the end of 2025. لكن استخدام الآن الجينيريتيف اي اي في الكودينج ولا بما يعرف الآن الفايب كودينج. الفايب كودينج الترجمة بتاعه البرمجة بالإحساس. هذا something that I am doing at daily basis. معناها I just need to express myself in English and the AI agent is going to do the code in a professional way in a very small amount of time. This is now the coding trend. لكن to have the best benefit of these tools you must have prior knowledge on software engineering skills. يعني ما نجوش نجيبوا شخص عادي ونعطيه ال AI agents هذوما it cannot do a sophisticated program. الآن we talk about supercharged software engineers. معناها supercharged software engineers. Software engineers that with good skills in software engineering but they are supercharged with AI. لأن ال AI they can help them to achieve their tasks in faster amount of time and with higher quality. لكن كله معتمد على ال prior knowledge that this software engineer would have. هذا ينطبق على كثير من الوظائف الأخرى. This is a very important question. Thank you very much. Yes.
The first one is about the metrics. What metrics are used to evaluate success and performance of the use of generative AI in business operations?
Yeah, there are different metrics depending on the type of agent. مثلا في الريتريفال augmented generation في metrics خاصة بالجنريشن في metrics خاصة بالريتريفال. المتركس الخاصة بالجنريشن مثلا the correctness of the answer. This is one of the metrics. بالنسبة للريتريفال مثلا نلقاو the relevance of the documents. مثلا وأصعب شيء في الريتريفال augmented generation هو the retriever itself. لأنه if you don't find the relevant documents so the LLM will be biased by these documents to generate the answer. وإذا الدوكيومنتس ما هماش صحاح الانسر تكون غلطة بنفس الطريقة. هذا بالنسبة للريتريفال augmented generation. الآن بالنسبة للمالتي كومبلكس agents في ما يسمى مثل السلايد الأخير اللي وريته فيه الcompletion rate. معناها how many iterations the agent is able to complete the task. طبعا we want to have the smallest number of iterations possible. أيضا الfailure rate معناها إذا كان خليناه يكمل التست how many times it has succeeded. الآن يعني with the new frameworks we are reaching مثلا 70% 80% over some benchmarks. لكن with the evolution of these agentic AI techniques I think we will be able to reach even something close to 100%.
So as a CTO of Scalix company involved in some works يعني innovative and using generation AI, generative AI. So can you provide, for example, some new world applications where
Yes, thank you. Yeah, now we have different in ScaleX innovation. We have two tracks. We have a track to provide solution to customers that would like to make business transformation, and another track is our platforms. So we have now a platform that is called reviewanything.ai. It's available. Anyone can access. It helps reviewing research papers and providing complete feedback on research papers and also proposing enhancement of the research papers. Another platform is called yourjob.ai, which helps human resources to recruit talents. Because, for example, when we open a position, you can have 50 CVs or 100 CVs, and just shortlisting these CVs takes a long time. So now we are using AI to make a matching between the CV of the candidates and also the job offer. And finally, we can have, even we can ask the AI after the shortlisting among 100 candidates, provide me the top 5 or the top 3. So we send everything to the AI, is going to find all the CVs, analyze them, provide us a recommendation with arguments. And now we're going, even with the notion of agent, we are going to automate this. We will make the AI even making interviews. Will it make matching, selection, sending interviews? The interview will be conducted by an agent. We have already a real-time agent that will conduct interview in English, in French, in Arabic. And then we will take the transcript, make an evaluation of the interview. We automate the full process from A to Z of the recruitment, from the CV submission until the selection of the candidate. Another platform that we are also working on is about education transformation. We have a platform that automates the creation of exams and the grading of exams using AI, and another one that will help better management of the course specifications, the accreditation, and maintaining different versioning of courses into a university. وفي عندنا في الهيلث كير and some others as well.
Thank you, Mr. Another question? Go.
السلام عليكم. Yes.
Prof. Koubaa, I have two questions. The first one is Agentic AI secure, or should we worry about potential dangers of security? And the second question is it free for our students here in Tunisia to test and train their models? Thank you.
Yes. So about the security, agentic AI are still prone to many security issues because this is something very recent. And I already shared the report from Microsoft 2 days ago, only 2 days ago, identifying security threats. I think this is a very important research topic for people working around security to explore the vulnerability of AI agents and possible security threats. I think like we talked before about SQL injection and so on, now we can have a query injection that will make the agent execute malicious tasks. So this is a very hot topic. Now about whether they are free or not, of course, commercial models are paid, but there are several open source models that you can download locally and you can develop your agent without paying anything. But you need to have GPU resources to be able to execute them locally on your computer machine.
Other questions? Yes.
Thanks, Mr. Anis, for this presentation. My question is, how can we deploy this model on locally on edge devices for real-time applications? Are there any lightweight models based on these architectures?
Sorry, is the question about deployment of the models locally?
Yeah.
Yes, okay, yes?
Is there a lightweight model? Is there a lightweight
Yes,
model?
there are so many models. Now, two popular framework to download models locally, there is Olama, and also there is LLM Studio. LLM Studio has a graphical interface. You can download the model and chat with the model through a very simple interface. Olama, it's used to download the model on your machine and then use it through APIs, through Python APIs, and you can create agents with Olama. Like for example, now LangChain, it has an Olama support and allows you to create agents, or to create chat APIs with locally downloaded models. المودلز صغيره الحجم 1 billion parameters 3 billion parameters حتى ال 7 billion parameters they could be downloaded locally. If you have, for example, 8 GB of RAM or 16 GB of RAM, you can download up to 7 billion parameters locally from Hugging Face.
Okay, another question, Professor Anis, is about the RAG system, okay, and in which conditions we need to develop our RAG system. And I am specifically thinking about applications like in order to help diagnosis in local pathology that are not known everywhere. For example, in Tunisia, we have the tuberculosis which has very specific features and characteristics and context, okay, for appearance and reappearance, disappear and reappear, okay. So what we should do really to have a system, okay, including RAG, okay. In my understanding, we have to gather all the local information and local knowledge, okay, of our doctors and the research made by our in the medical field about this pathology. We have to gather all of that text, article, science, knowledge, etc. And we have to develop like a vectorized system database with all this kind of graph, etc. And we have to develop this rack system, and then we can make a kind of solution that support our doctors to have the right diagnosis of this pathology, for example.
Yes.
Okay, is this right? And my second question is about your project on Arabic LLM. I want to hear you talking about a little bit about the challenges you faced.
Okay, very good question. So for the first one, for any rack system, there are two main components اللي هي retrieval والgeneration. الجنريشن أمرها سهل يعني now just to معنى summarize, if you have a good retrieval and a bad LLM, the performance will be much better than if you have a bad retrieval and a professional LLM. لأنه ال LLM will be biased by the documents that will be retrieved. So, and this is the important part. Now, how to implement a retrieval? Of course, we need to have data. A very important thing is that this data must be clean and accurate. هذا أول نقطة. النقطة الثانية, the way how you chunk your data مهم جدا جدا جدا. هل تعمل small chunks ولا big chunks ولا semantic chunks? How to chunk your data? هذه نقطة مفصلية جدا. And there is no universal solution. في hybrid chunking, في semantic chunking, في character based chunking. كل use case you have to think about what is the best strategy. Okay. فهو أحسن شيء أنه الchunks يكونوا عندهم coherent semantic information بحيث أنه يكونوا متوسطي الطول ما هماش طوال برشا ولا قصار برشا باش لما تلقى المعلومة تلقاها في chunk معقول ويعطيك المعلومة المناسبة. فالداتا cleaning for retrieval system is very crucial for the accuracy of the retrieval and the overall accuracy of the performance. بالنسبة للأرابيان LLM, that was one of the first initiative على حسب علمي اللي في خدمة اللغة العربية. طبعا there was a lot of challenges منهم data challenges and computing challenges. بالنسبة للداتا يعني كان إشكال كبير في اللغة العربية الآن بدأ ينقص لأنه أصبحت الكثير من المؤسسات تشتغل على اللغة العربية وتجميع البيانات، لكن في ذلك الوقت كان تجميع البيانات أمر صعب، والبيانات اللي تجمعها مش بالضرورة تكون very clean، فتأثيرها على النموذج كان واضح. مثلا لما استعملنا تويتر داتا يعني نموذج أصبح يعطينا بعض الأحيان toxic outputs. طبعا في بعض الريميديز وكل، لكن على small model it was very difficult to manage this toxicity. ايضا بالنسبه للكمبيوتنج ريسورسز رغم اللي كان عندنا 8 GPUs A100 لكن هذا ما يسمحش باش انك تدرب نماذج كبيره جدا. في many challenges in terms of accelerating the training for large language models سواء كان عربي ولا غيره. طبعا احنا to optimize the training كنا عملنا توكنايزر خاص، عملنا embedding خاص، وهذا ساعد يعني في كثير من المراحل to optimize the performance of our models.
Okay, just to complement the question about the RAG system, يعني, about the chunk, to make the chunks. Most of the knowledge we have in medical or even in biology, okay, in local knowledge, Tunisian knowledge about biology, about agriculture, about we talk about bacteria, insects, medical pathologies, healthcare. Most are image-based curves, diagrams. So most of the knowledge is represented like that. It's not text. Okay. For sure, we have. You may know that in Tunisia we have, let's say, tens of thousands of publications just in biology, agriculture, and medical stuff. And what to do with that? So do we have to like and consider developing rank systems in order to bring the value out of that, okay, local value or what?
Yes, now rack systems are not only depending on text as but we can now vectorize images and text. في الآن retrieval فيديو based retrieval systems. الآن نستطيع نعمل بحث في فيديو، مثلا نسأل في الفيديو هذا أعطيني مثلا فيديو اللي فيه مثلا 4 أشخاص ولا اسم فلان ولا أي شيء. الآن it's possible، والعملية تكون أنه كل بيكتشر في الفيديو يكون معه نص وتصير عليهم فيكتورايزيشن الاثنين مع بعض، بحيث أنه السيرش لما تعمل بالسيرش بالتكست بالنص هو يبحث على أقرب نص and each corresponding picture. This is possible. There are many solutions on how to vectorize images and text captioning, and this can be applied حتى في الميديكال أيضا. طبعا الآن هو مستعمل في generating reports for X-rays مثلا. This is one of the most active area في الميديكال كير، أنه نعطيه صورة ويعمل لي report generation. This is one of the works that we started to work on. It's in big demand يعني automating the report generation out of X-rays ولا CT scans يعني medical images.
Excellent. Thank you so much.
You're welcome. Thank you.
Okay,
Thank you very much. It was a pleasure.
donc la session est achevée. Je vous remercie pour votre attention.